Okay, we're still on Unit 1, Lesson 4. We're now on page 3. We are trying to solve word problems by translating words into mathematical equations and solve for unknowns, Part 2. We had the abstract problems. Now we're going to have what I call the part problems. Most word problems are not abstract. Many fall under the category of part problems. An equation can only be solved for one unknown at a time, so only one variable can be used in the final calculations. If there are two objects in a problem, one object, the smaller or cheapest, is the variable with a numerical coefficient of 1, and the other is more or added to or multiplied by something for the variable. Okay, so let's start with simple and get harder here. So example 1 says the pet store has 11 tanks of fish. Each tank has F fish. Using F, write an expression for the total number of fish in the store. So you can draw a picture. We have 11 tanks, right, etc. And each tank has an F number of fish in it. So are we multiplying the 11 times the F? So 11 times F, and that's 11 times F, and you might as well just write 11F. That's an expression, 11F. Just, it doesn't, I didn't mean to put any space between them. Remember, things shoved together implies a multiplication. 11F, yes, some of the questions are that easy. Number 2, Kaylin had $40 to begin with. She just spent D dollars. Using D, write an expression for the number of dollars she has left. So you must have subtracted D, right? And this expression represents the total of dollars she has left. That's all we're trying to do, is to use variables for unknowns, taking these words and make them into equations or expressions. Okay, so yes, there are some easy ones like that, and then there's some that are involved in equation. A sofa and a love seat together cost $444. The sofa costs double the love seat. How much do they each cost? Write an equation using X and solve. Notice that the sofa is described in the terms of the love seat. Okay, so a sofa is larger than a love seat. So the sofa gets compared to the love seat. So the love seat must be X. And the sofa is 2 times as much as X. Okay, because the sofa costs more. It costs double the love seat. So 2 times as much is 2X. Okay, so the cost of the love seat plus the cost of the sofa equals the total together of 444. Okay, so 1x plus 2x is equal 3x. I combine like terms on one side. Then I isolate my x by dividing both sides by 3, and I get x equals 148. Well, what was x? X was the lower cost item, which is the love seat, cost 148, and the sofa was 2x, so this is 2 times 148, which is up here, I think. 2 times 148 is 296, and 296 and 148 equal 444. You have to check that. Okay, does that make sense? The sofa is the bigger thing, like physically, and it costs more. Okay, so love seat's smaller and cheaper, so it's going to be the X, and the sofa is going to be represented by the expression 2X. When you add them together, you get the 444. Okay, and then you solve for X. Let's look at another one. The cost of a certification course is $1,575. An in-person portion costs $725 more than the online portion. So what's the two things? There's an in-person portion and an online portion. So this is the total. Get my pencil going here. And then you have an online portion and you have an in-person portion. Okay. In-person costs $725 more than the online. So the in-person is larger. Okay. So it's larger than the online. So the online is X. And how much bigger is the in-person? Well, it's X plus 725. You can tell by the question, it says use the variable P for the unknown, and I just used an X. I should finish reading the sentence. Number one rule in reading your word problems is get all the way to the end. Okay, if you don't do it in the beginning, do it at the end. So what cost does each have? So I'm going to be adding them together to get the total again. So this is going to be P plus another P plus 725, okay? Because it's the online portion plus the in-person portion, and the total for the course is that. So I have one P here and one P here, so I have two P's when I combine like terms. And I have to isolate my term that has the P by moving this to the other side. So this is going to be 2P equals 1575 minus 725 is 850 divided by 2. P equals 425. All right, what's 425? The online is $425, and 425 plus 725 $1150 for the in-person, 425 for the online, and just a quick double check, 1150 plus 425 better equal the 1575 that I started with. Okay, we're using variables to solve word problems. All right, last one. We have a bag of marbles. All right, it contains 69 marbles. Some are green and the rest are blue. So we have green marbles and blue marbles. There are 25 more green than blue. How many blue? How many blue is what they're asking. So they want to know how many green as well, just blue. Write an equation using the variable B and solve. It's a capital letter B. All right, so I'm just going to say green and blue. So I only need to use that one letter to represent the number of green and the number of blue. So which one is bigger? Which one had more? Well, 25 more green marbles. 25 more. It's something plus 25. Well, that means blue is the B, and blue plus 25. So this is the number of blue marbles, and this is the number of green marbles, is represented by this expression. So you have the number of green marbles plus the number of blue marbles equal to 69. Okay, so then I'm ready to solve. This is my equation I need to write down to show I've translated the words to numbers into an equation. And this is 1b plus 1b is 2b's to combine like terms. And then move the 25 over. 2b equals 44 divided by 2. B equals 44 divided by 2 is 22 blue marbles. And if I just want to check, if I have 22 blue plus 25 is 47, plus 22 is 69 marbles. Just checking, but my answer is that. Okay?